Hello there. Let's talk about what we are going to cover in this lecture. We will cover callbacks, promises. You will see difference between these two, and we will cover promise chaining. We will cover promise APIs, which is all, raise, any, all settled. We will learn about what is Promisify. We will learn Async Await syntax, how it works with examples. And we will understand how we are going to handle the errors. Also, we will see what's going to happen if we don't handle any errors, how we catch them. Also, we are going to explore this diagram, how things work, what is differences between Web API and job queue with the examples. So we're going to cover a lot of things. If you're ready, let's get started. Let's see what is callback, and later we are going to see them in the examples. In JavaScript, functions are first-class citizens. Means you can pass function inside function and you can return that function that you pass. So when you pass a function into another function, that function you passed is callback, so that you can use that function later in the function. Also, you can pass anonymous function as an argument, means you passing function on the fly. This is callback, and this is also callback. It's arrow function. If a function accepts another function as its argument, that function is higher order function. And simple example like this, let's say you pass array and then you pass the function, which is callback. And since this function takes a callback, means this function is higher order function. This is just a quick note that we have synchronous and asynchronous callbacks. We can have success or failure callbacks. If you put function inside function and then inside that callback you put another function which is callback, and it will bring you what's called Callback Hell or Pyramid of Doom. And this is really huge problem. We never want to do this. We don't want to use callbacks if it's not necessary. But still, we have to really understand how it works, because you are going to see a lot of callbacks in the codes, even though you can accomplish the same thing with the promises. So to prevent this problem, we have new way, which is promises or Async Await functions. We will see them, we will cover them. They are all powerful, but we really need to understand callbacks, because if you don't understand this one, you can't use this two properly. Let's see the examples. You can see that we have a function and we pass an array in it, and then we do some logic inside, and then we fill this variable, then we return it. And this logic gives us the odd numbers. So when we pass this array inside, it's going to give us the odd numbers. Let's save. We got the odd numbers. Well, nothing wrong with this code, right? I mean, it's decent code. But how we can improve this? Imagine that you want to do not odd, but even numbers. You would have to copy this and like that, and you would maybe do this. But still, as you can see, if you do, let's say 2, you copying so much things, and they almost same with each other, except this one. Let's improve this problem. This is the new function that we improved. The name is just more generic, and we pass array and we pass callback function, our callback. means this is going to be function. And we're almost doing the same thing. You can name this anything that you want since the callback is going to be different. You can say A to clarify, or you can just put this one in here. It doesn't really matter. The key thing is that we're calling the callback with the number that we looping over. And these callbacks are these two, depends which one we pass into. So let's assume we pass this one into, and this is a function which takes a number, and this is why we pass the number inside. And what it checks if this is odd or not. So if it's odd, it's going to return true. And this is why you can say is true or is number, whatever you want. Let's say A, or just is true, to make more clear. And now it's going to check whatever we pass as function, and it's going to give us the result. Now we improved our code. And this is the whole idea. By the way, this is the higher order function since it takes the function as an argument. This function is higher order function. Now if we save and if I do odd numbers, it's going to give us this. And if I say even numbers, it's going to give me the even numbers. Let's move. Another use case for the callbacks to doing things sequentially means, let's say you want to download a video and after that you want to run that video, right? Because if there is no video, you cannot run it. Imagine that you have a task like that and you want to achieve first it's going to download and to wait, and then it's going to run. As you can see, we have download video, just pass the video name into, and we have run video. Again, we pass the video name, we console log things, and we have do video job function. In here we have setTimeout. This is a web API function, and this means it's going to run later, no matter what. If something is web API code, it's not going to run in this line. It's going to run after everything finished. So if we save, we see running video and download video finished. By the way, I will cover this in detail soon. Let's first understand why we have to cover this. And the reason is that, as you can see, we have running video and download, which is we don't want like this, right? We want to download our video first and then run our video. This is the problem. We can solve this problem with many different ways, and one of them is callback. But before that, I really want to mention about this one quickly. I'm not going to go into the deep execution context or things like this because I need to prepare new video for that. But let's talk, what is this? Let's talk about this example. The main takeaway about this one is that Promise code and the web API's codes are not running immediately. It means the JavaScript, when sees these things, for instance, this is a web API, and let's say if there is a Promise.resolve, and when it sees promise, we will cover this, don't worry. It's when these two cases encountered, JavaScript will never run them first. Never forget that. This is extremely important. So what does this mean? It's not going to run immediately. We have something that's called call stack, which is the jobs that the program will do. So right now we have console log, and it's going to be in here because this one is the first one. And if there is another job another job, another task, or it's going to just stack like that. And this one, the top one, is going to run the first. This is why it's called last in, first out. Means the last one is going to run first. But in this code, we don't have functions or things like that. So it's just simple one. Right now, when we say console log, it's going to see that and it's going to run it. But when it says set timeout, it says, oh, I can't handle this. I know it's there, but I will just give this task to Web API. So it's passed to Web API, which is this one. It's just another task like this task list, and it's going to stack like that, how many of them you put. So this one, the first one we put, it's going to be this one, and then this one, it's going to be in here because it's going to read line by line, and then it's come here. As you can see, it's 0 seconds. We are saying wait only 0 seconds, and then it's going to be here and here. So JavaScript can't handle this, and it passed to this task queue, callback queue, and whenever JavaScript finish its entire job in here, then only then it will accept whatever is in here. So it will start accept take task from here when they finished. And then event loop is going to help JavaScript engine to communicate with these two. For now, ignore this one, just focus on this one, and it will take from there and it will pass here and it will run. And this is what it does. We say set timeout, after 1 second run this code, and we say run this code and this too. This one is first in, first out, means it's going to take this one first. But the time is, as you can see, is important because the event loop is going to take whatever finished. So as you can see, these two are 0 seconds, even though they are in here logically. But since they finished before the 1 second one, the event loop smart enough to take this two first. As you can see, the order is not going to mixed, and this is why it's first in, first out behind the scene. The order is not going to change. Let's see how it's going to log. Let's save. And we got header 01, header 2, because these are going to pass the web API. It's not going to run, even though it's 0 second. And then 3 is going to log because 3 is before 4 that goes in the web API. So the order is going to matter when they finish at the same time. And this is why we have these logs. If we had something like this, well, this one is going to finish first because it's 0 second, right? You see, the 4 is finished first. If you do this, 0, 20, 1000, 1000. Let's back to our topic since we understand this. Our question was how to prevent this behavior like this with the callbacks. Let's see how we can do this. This is improved version, but as you can see, we're not using the callback. We are just going to understand how this thing works. We do set timeout and a function, and we are doing our job inside the set timeout. since we know this code is going to run after 1 second, and the order inside it, it's not going to change because it's going to run after 1 second inside itself. Like, these codes are going to run correct. So when we do save, well, you can see we have the order we want. I hope this is clear, and let's see how we can handle with the callbacks. Now we have the same function, but we pass the callback, and maybe we can pass also the arguments if we want. And this is the millisecond, and this is the video name that I pass. So it's going to be dynamic. In the setTimeout, we have the same logic, but as you can see, we run the download video with the video name, and we run our callback like that, and we initialize our function. Let's save, and the order is correct. Also remember, you can do this too, right? Let's say callback 2, and I will do like that. And instead of doing this, I will change this and save. And it's going to be same result. This is what is callback. And we're going to see more advanced examples. What is Callback Hell? Well, previously we did, let's say, video 1, right? We download and we run it. But let's assume we have 10 videos. And we want to do with the orders like download video 1 and then run it, and then download video 2 and then run it, and so on and so forth. We can accomplish this with the callbacks. So when we put the callback inside, we do, let's say we pass the callback, and inside this callback, we will again call the task that we want. It's going to work, but it will bring problems. Well, you can see we have this function, and we put our function inside, which is our callback, and we do this too, and then we call another callback. And that another callback is the function that we pass on the fly, which is another function, right? And this function also runs the same thing, like this. When we save, well, you see we have accomplished what we want. We download video 1, we run it, and then we download video 2, and then we run it. And if you want to see the bigger example, I'll just copy. And now, as you can see how things get complex, we pass our function, means callback, and then inside it we calling the function, but again we pass the callback, and inside that callback we pass another function, and so on and so forth. And when we do, let's say this one 5 and save, well, it's going to work, right? But it's really hard to manage, right? Even when I'm trying to explain, it's really hard. And imagine it's complex code, and readability is extremely important. And this is why we want to prevent callback hells. We don't want to use code like this, but we have to understand how things work. Also, in real life, normally what you have to do, you have to handle when the error happens inside here, let's say. And each function, each callback, you have to handle the error, and you handle this error, this for function, and this one, and it's going to be insane. Let's move. Let's talk about success and failure callbacks terms. we have these two same functions. In here we have do not run, means we have an error function. In here we try to do our job for the task, and we do download callback, which is we try to download video, and we have success callback and failed callback. Inside here we initialize the download callback. Let's say we download success, right? And we want to check if it's downloaded or not downloaded. In case if it's not downloaded, it's going to run the failed callback that we pass. And it's going to run failed with this message. If it succeeds, it's going to run the succeed callback. So with this syntax, you're removing complexity. And this logic is extremely important. You're going to encounter this almost everywhere. So please pay attention of these things and try to write the codes by your own if you're not familiar. I'm not typing codes like this because it's going to take a long time, but sometimes it's going to be necessary for me to type the codes for you to understand things better. And in this situation, I'm going to write the codes step by step. Let's move. This is about error first callback term. And this is a convention, means usually you put the error, but if it doesn't have any error, you do your work. And this function is handling errors. And this is why I put handling things, or you can say handling errors. If it doesn't have any error, it's going to do things whatever you want. So as you can see, it's first check, hey, is this any error? Well, if you have any error, then I will inform you, but then I will return, I will finish. Because you have error, I can't allow you to do something else. And let's say you want to do your laundry and you need the laundry basket. We have work, we have callback, which is handling things, which is error callback, you can say, or generic callback, since it's going to handle error. If the error doesn't exist, it's going to do your job. This is why we can say it's callback. I mean, the name is really not important, but you have to see, you have to understand the logic, what we're doing. We're passing this function into here. And then based on this, we're doing something. So we say there is no basket. And this is why if there is no basket, then I cannot do, right? Because this is going to be false and this is going to run. And this one, what is this? We passed the error message, right? This callback is this one and this one is this one. Now we pass this one and it's going to log this one. Let's save. It says there is no basket, mom. So I cannot do laundry. But if you give me the basket, which is true, is basket exist? Yes, it exists. And then I will ignore this one. I will pass to null, which is this one is going to be null. And since this is null, it's not going to trigger here. It's going to run your job. So what is my job? Is this one, laundry work done. If I save, laundry work done. This logic is extremely important. Get familiar with this, write this code or do something else and try to do error first and then your job if it succeeds, and you will use like this. If there is no error, you pass them all. If there is error, you do this. Also, if you put something like anything in here, it's not going to run, right? Because in here it's going to return. If you even pass the job, right, it's not going to run because you return in here. So this doesn't matter. You can just leave it, you can do null. Well, if you leave it, it's going to be undefined by default. So let's move. Let's talk about synchronous and asynchronous. If something takes time, and usually you don't know how much time it's going to take, this is asynchronous. When someone explained asynchronous like this to me, it was always confused me, because I was thinking, okay, if something takes time, well, let's say you have a loop, and a loop is, let's say, from 0 to 1 million, and you start to loop over them. Well, eventually it's going to take time, right? And I couldn't understand what's the difference. Like, this is also take time, right? How I would know if something is synchronous or asynchronous? Remember, in code, when you have something like this, the program knows how to deal with these things. And for instance, like for loop, the example I gave about the loop, when the program runs this, well, it's going to take time, right? But the program knows how to deal with it. The reason it takes time, it's not because it's a task is going to take time. It's about when the program run these things, like program know what is 0 is, what is 1 is. It doesn't need to ask somebody else. And program knows what its console log is. It's inside the program itself. So this is why it's not asynchronous, it's synchronous. And these are also synchronous, means you see it's synchronous. And when you do this, we will come here, I will explain this, and then it's going to keep moving. It's not going to wait. And JavaScript is synchronous. Okay, don't forget that. It will never wait for somebody. If the code is asynchronous, it's not going to wait for it. If you can wait for it if you want, we will come there. But JavaScript is not going to wait unless you don't tell him to wait. Anyway, if something takes time, even if it takes 0 time, if it's asynchronous, it's asynchronous. For instance, promise and setTimeout are asynchronous tasks. Whenever you see this two, and this is the web API, and this is the promise into language, they will never be like synchronous code. They are different. It's going to handle them by different strategies. So whenever you see promise and setTimeout, it's going to, JavaScript going to say, hey, I can't handle these two. I can't handle promise, or I can't handle setTimeout. Please help me. It's going to ask outside. Let's say we have a people and we assume that it's going to be a synchronous task. We are getting from the database like 1 million data, and let's say it's going to take 1 minute, and this is asynchronous. This is a synchronous task, because we don't know how it's going to take. Maybe it's going to take 2 minutes, who knows? And it's going to take some time, even if it's milliseconds, even if it's 0 seconds. It has to be handled outside of the JavaScript. And then when it's ready, we will get the data. With examples, we are going to cover them much clearer. Also, I would like to mention again about this diagram. So imagine we encounter with the promise or setTimeout. The promise is going to go in here, job queue list, you can say. And the setTimeout, since it's web API, it's going to be in here. So JavaScript will pass them, hey, I can't handle them, please do help me. And it's going to give the task in here and in here. And then JavaScript will finish its all the synchronous code, like from top to bottom. It's going to run everything. Only when everything is finished, then it will start to take the things done from there to, it's going to get them whenever they are ready. And the priority is going to be first this one, second this one, about checking. So the promise priority is more important than this one. Let's say you have set timeout 0 and Promise.resolve, we will get the promise. Let's say they both synchronous and they both resolve, means we get the result at the same time, and the priority is going to be for this one, promise. So event loop is going to take this one and give it to the JavaScript. So the main takeaway is that asynchronous code is going to be handled from this two, not inside here. You can't do in here. This is a synchronous task. Let's move. Let's understand what is promise. Firstly, the purpose of the promise is to solve the callback complexity. And for this purpose, a promise is an object that encapsulates the result of an asynchronous operation. Let's give an example. Imagine that I'm saying to you that, hey, I am promising that I will make a video about the promise in the JavaScript. Or you can say just, I will create a video. Okay, you make the promise to somebody. And just like this example, in the JavaScript, also the promise is like that. They have states, and it's pending, it's fulfilled, and it's rejected. These are the states. So if you fulfilled, you will have a value. If you reject, means you failed, you will have reason for you fail. Back to our example, when I say, I promise that I will make a video to you, this means I did the promise, which is a pending, right? Because I cannot make video on the fly, right? It takes time. So after some time, I will make the video, means I will complete. If I complete it, it's going to be fulfilled, means I succeed. And you will have a value. In this case, the value is the video that I have made. But let's say I couldn't finish. Maybe the reason is I changed my mind. Hey, I changed my mind. I just don't want to make the video. Or maybe I moved the other country or something, any reason, you know. If you couldn't make it, it's rejected. You don't have that video at the end. And there is only two possible ways. You can think the promise chart like this. I made a promise to you that I will make the video about promise and it's pending. Let's say after 10 days, I finished. It's going to resolve. We have the video. It's fulfilled state. It's on fulfilled. But if I couldn't make it, it's going to be reject state. It means I couldn't make it. And once you keep your promise or you couldn't keep it, you cannot go back. You cannot say, hey, let me make my promise again. Can you let me? No, this is not possible. You never ever can go back. You can create promise from scratch, but when a promise settled means either fulfilled or reject means settled. This promise is settled. You cannot go pending state again. This is not valid. Let's move. In this example, we are going to understand asynchronous in better way. We have a function that we get the movies and we want to find movies and we run the find movie function. But as you can notice, we have set timeout, right? But let's move step by step. In here, we do const movies and we do get movies. We initializing this function. Once we initialize, we will run the function, which is we do let movies, and then we come here. This one is going to run. And then this set timeout, remember, it's JavaScript will see this, but say, hey, I can't handle this, right? It will give the web API task queue, remember? And it will move on. It will run its synchronous code, which is this one. And it's going to run this, and then it's going to console log movies. In this case, what is this? It's going to be empty array. And then we return empty array. Now, this is an empty array. We are trying to find movie inside an empty array, which is going to be what? Undefined. It's not going to find it. Let's save. And you can see we got this, and empty array, which is this one. And then we got our undefined, just we explained. Let's solve this question with the callbacks. Since we said we will solve this question with the callback, we have to pass callback inside the get movies function. We passing callback, we have to create this callback, right? And we creating this callback in here. We initialize the function with our callback. And let's see, we do this and we again log. We do set timeout. You know that it's going to again go to web API, and we got to this and we just log in the movies. Then we get the empty array again, right? Well, we get the empty array, but remember, we passed the callback function. And this callback function, it's going to happen whenever this set timeout finished. And we, let's say we do dummy movies like this, and we do callback movies. We running our callback inside set timeout function. So after 2 seconds, when web API start to run this code for us, it's going to run our callback that we pass, which is this one. And we say movies data, and we pass movie in here. Now we try to find our movie from movies data. And eventually we are going to find our movie right in here, because this code is going to happen 2 seconds later, because this is callback that we pass into here and we call inside setTimeout. And this is why we will able to get our found movie. Can you see this? This is what we done, right? But if there is another code in here, let's say, I don't know, some dummy log, whatever, we said JavaScript is going to see this. It's not going to wait, right? Well, yes, it's not waiting. It's going to move on. And if there is something, it will start to do it. JavaScript initialized this, but it's not going to wait. It's going to move on. So if there is code in here, it's going to move on. It's going to run this code. Let's save. As you can see, it takes time. It takes 2 seconds to get this data because, well, you can see we do this log and we got this one, and the movies is empty, as I said, because JavaScript is not going to wait. So we get the movies, but notice that in callback, we asking movies data and it's going to be in here. And this is why we succeed to find to movie name, which is movie 1. And we get the movie 1, this one. If I console log this one, like this, let's save. See, this is 29 and it's in here. As I mentioned, this code is going to initialize, but JavaScript will not wait for this. It's going to move on. And since it's moving on, we get the dummy log, which is in here, and then we get this log, which is movies. What is movies? It's empty because we return empty from here. If you're really not familiar, it's going to take a bit time for you to understand. And by the way, if you don't call this one, it's not going to initialize, right? If you forget to this one somehow, it's not going to initialize your callback. Now, what is the problem in this code? Seems everything works. Well, there is no problem in this code, but it's really hard to read, manage, to code. And especially when things get more complex, it's really hard to manage things. And this is why we're going to learn Promise. And Promise is going to solve these problems that we have. But again, we have to really understand what's happening behind the scene. Otherwise, we cannot use Promise effectively. Let's move. Let's understand promises in details. Promise accepts a callback which calls executor. And this callback accepts two callbacks, which is resolve and reject. And they both provided by JavaScript. You don't have to create or do something. It's just there for you. All you need to know how to use them. And the syntax is like this when you create a promise. And this is the executor that we set, which is a callback. And this callback has two callback inside, which means this is resolve and this is reject. They are callback that we pass into executor. And usually you say if something that you want to do, if it's true, let's say if number equal 1, if it's true, resolve means you want to say, yeah, this is fulfilled, and then reject if it's not. If operation completes successfully, executor will call resolve and state of the promise from pending will change to fulfilled. When this happens, it's going to be fulfilled. If this happens, it's going to be rejected. It's here as you can see. So you can move from pending to fulfilled or from pending to reject, just like the diagram I showed you and the example I gave you about the video. And as I mentioned before, if you hit the state of fulfilled or reject, you cannot go back. You can't change state. We rarely use the promises manually, but we usually consume them. Sometimes we use the promises manually. I put this in here, but what I want to say that you have to create manually if you really want to understand. If you don't understand how things work, you can't use properly these things from the libraries. So creating promises manually is extremely important for us to understand what's happening, how things work. Because at the end, you're going to use the asynchronous await, which will create promises manually for you behind the scene. We will come there, don't worry. This is just a quick note. And don't think that you don't ever need to create manually. You have to create them to understand. When we resolve, we will resolve the value. When we reject, we will usually reject the reason, the error reason, and this is why it's reject. When you create promise, the executor is going to run immediately by itself. We mentioned about this, but let's mention again. When promise either resolved or reject, we call this promise settled. Means whether I kept my promise and I made the video or I couldn't make it, this is settled. Any of this, if it's happened, it's settled, it's done. And promise always initially is pending. And after it's settled, you cannot go to pending. It's done its job, that's all. Resolve and rejects are accept only one argument or none. You can ignore the value if you want, but you cannot pass more than one argument. I mean, most probably it's going to ignore, but this is how it works. It's accept only one argument. Properties, state, and result are internally handling by promise object. We cannot change or access them. So we cannot access the state basically or change the state manually. Let's quickly see how it's look like the promise object. As you can see, this is promise object and we like this static methods, and you can see we have reject, resolve, which we use in here, and this is what it is. Let's move the examples. In here we create a promise and we just resolving the promise. Since we resolve, it's not going to even read these things. It's going to be ignored. Think it like when you return in the function, it's not going to read the below code, right? And this is the same. When you resolve or reject, let's say you reject in here, these things are not going to be read, like they are not existing there. It's just going to reject. But how we can use these things, right? How we can consume them? Let's talk about then, catch, and finally. If you want to get the resolved value, you have to use the then method on the promise. Also, notice that we call the then method on the instance of the promise, which means the then method is going to be on the promise prototype so that the instance can consume it. Then accepts two callbacks means when you on result or on reject. We usually only use this one. We want to get the value from the promise, but if you want to also handle the reject, you can do with the then. But we will talk about this a bit later. Let's see how things work. We have a promise like this, simple promise, and we say if true, resolve, which will be true, right? It's going to run this one, and this one is not going to be run. We have this instance, and we would like to use the then method. When you use the then method, as I mentioned, you can pass two different callbacks. But let's just ignore this one for now. Let's say I just passed one single callback and we getting the answer, right? We say, hey, give me the resolved value. And this answer is whatever this is. And we logging the answer. Let's see. We got 1, 2, 3, just exactly what in here. So the first function inside the then method is when it's resolved. But if you want to handle also the error, well, in this scenario, we don't have any error. We will still get this one. That's again refresh. You see, we get again this one. But if I turn this to false, now this is going to run, right? Since we don't have any resolved value, this callback is not going to trigger. This one is going to trigger. And when we save, as you can see, we log the error, which is rejected, an error. And this is just a silly log that I put to make sure this code is run. And it's run. If you do console log some save, you see this didn't trigger because it did not resolve. So the key takeaway, when you use the then, you will get the resolved value, whatever you resolve. If you resolve this, you will get this value. Let's move. What is catch? Well, catch is for to handle rejected value, rejected error that you get. So when the state of promise rejected, you can catch it with the catch. And the syntax is like this. You just pass one callback inside, and behind the scene it uses this concept, but I'm not 100% sure if it's really using the then method behind the scene or not. But it's not that important. The key thing is that the catch is catch the error. Like I said, the then method, the first one was the resolve, the second one was the to find the error, but you almost never going to see that in code the then method is going to catch the on reject. We just don't use it, so we keep things simple. So we use then for the resolve and catch for the reject. That's all. Now if I do like this, if I save, we catch the error. Just to make things more clear, if you pass the null for the first in the then, as you can see, we can catch it again, but we don't want to use this syntax, right? Just use catch for the errors, then for the resolve. Let's move. Based on knowledge we have right now, I would like to ask, what is the difference between these things? Are they same? Do you see any difference? Pause and please think about it. Ready? Let's think together. Well, we said then we can pass to callback, and this one is going to handle for the resolve and for the reject, and it will get the error inside the promise. But in here, when we do promise.then and function to get the value that is resolved, the result value from promise, remember? But what if I do inside here some fancy thing, with that value I got? Maybe I like to fetch some data with the resolved value from here. While doing this in here, maybe I failed. And if it failed in here, the catch will able to catch that error for us. But if I do in here the same logic, the getting data or something fancy, there is no way for us to catch this error. I mean, you can do try, catch, whatever. You cannot, this is not going to catch the error inside here. And this is the difference between this syntax and this syntax. And this is why we would like to use this syntax. Let's move. What is finally? If you know try, catch, and finally syntax, this is the same concept. So whether the promise fulfilled or rejected, your finally code will run no matter what. Let's say, remember our example that I promised to you I will make the video. Now imagine whether I failed or I succeed. I would like to make an announcement so that everyone will understand, will see if I failed or not. So I will publish this information with the people, no matter what. So if I finished, I will say, hey everyone, I finished my video. I kept my promise. If I didn't, I still want to make an announce so that everyone will know the reason, maybe. You got the point. And this is the same. And you can think behind the scene, when we use the then method, whether it's resolved or reject, we want to run a function. This is not really what's happening behind the scene, but this is if you want to understand better. And also, finally, doesn't have arguments that accept. So this syntax is not true. It's just for us to understand better. We can use finally, let's say we get the data from database and we want to close our connection to prevent errors, or we want to close the sessions, things like that. And it's perfect case to use finally. Whether you get data successfully or with the errors, you still want to close that connection maybe. And finally doesn't outcome of previous handlers. Let's see these things in example. We have promise, we do then, we do catch, and we do finally. And if we save, since we resolve, this is going to run, and this is going to log, and the finally is going to run no matter what I will run. It's going to run. If you do this false, this is going to trigger, and the finally is still going to trigger as I mentioned. Let's see another example. What do you think about the log of this code? We have promise, we just do finally, and we do then after it. Normally we would think, okay, if it's finally, then it should run after, right? But this is different. We put the finally before. Let's save. And as you can see, the final runs and then run, and this is our result. So in this case, finally will run first. What if I change code like this? We put catch and we do reject in here. What do you think about the lag of this code? If you can't guess, it's completely fine because it's a bit hard to understand. Well, we reject right in here and we do finally. Since we do finally, it's going to run this. Once it's run, it's going to run this. So this catch is going to handle whatever error happens before it. So it sees this reject and it takes it, it's going to log it, and then the then method is going to run and the result is going to be whatever the catch return is. In this case, it's a promise. Let's save, and final runs error we got in here, and then this method is going to take the value from here, the catch one, and it's going to log it. In this case, it's going to be undefined. If we do like this, since we return this, it's going to take whatever we return from here. We get the result. We get the answer from here. Let's move. Let's understand this example. As you can see, we reject a new error like this, and we throw an error like this. Remember, when we reject, it's not going to run the other thing. But what I'm trying to say in here, they both equal. So when you throw something, it's automatically is going to reject the code. So these two things are equivalent to each other. You can use which one you prefer. And we do finally, and we try to catch the log. Well, probably you can guess, and finally is going to run, and then we catch the error. What's going to happen if we do this? Well, let's think we want to get the result value from this one, and we want to log it, or we just want to log and then do dummy log. But our code is not returning, not resolving something, right? It just gives an error. And this is why this code is not going to trigger. Let's save. Let's save again. You see? Let's move. In this question, these two are equal, so I will just remove one of them. We have then and catch. You can see we return from finally, right? Will we get in here or not? Let's save. We logged our finally in here, but then didn't trigger. Means we don't have this value in here. But catch runs, and catch getting this error. If we do this and save, now catch will catch this error. You can have multiple handler like then, and at the end only one catch will be enough to catch errors. Let's move. Let's talk about this example. I'll just save and we will get the answer. Now we catching the error from here, which is this one, pay from error, and we have then method. Then tries to get the value from here, but we get the undefined because we're not returning anything from here, and then we get the slack. And after finally runs, it just run and throw error in here, and we do catch, and we catching this error from here. if I come here and do return something like this, now if I save, I'm catching this value inside here. I'm getting this answer, and I can see the message in here. Let's move. You remember this example, right? We try to get the movie that we want to search and we like it. When we save this code, you see that we got undefined in here. This is because JavaScript will run this, but it's not going to wait for that. And it tries to get A, but it's undefined. But we are getting our movie from here. I hope these things are clear to you. Now, our task is to convert this to Promise. Please try by your own, and if you're ready, let's start to it together. This is the code that we want to convert to Promise. So I just removed everything inside, and we also need to remove this one because we're not going to pass any callback. So let's start. Since we are saying this is going to be Promise, and we have to do new, and inside we have let movies, and then we have setTimeout. Now we will implement the same logic. I'm just going to copy this one because I don't want to type it. Now the key thing is that when we do new Promise and we want to get the result, right? So what is the result that we want? Well, we want to get movies, right? So that when we do get movies, then we will get our resolved value. Now this code seems good. It seems going to work. But what about this one? Well, notice that we are passing something, and we also want this code to be Promise because this is the whole idea. We will convert these things to Promise. So we will do return new Promise again. So you can do resolve reject. I keep things short. Now remember, in here what we do, we get the movies, right? But we pass the callback because this is the only way that we can get the movies, the true movies data. But in here, this is Promise, right? So we don't have to pass callback or something. So we will do get movies. We will initialize our function, and then we will get the value, which is movies. Let's give it to movies data, so it's going to be different from the movies to make things more clear. Now I am able to use this data inside here. So what I'm going to do, we do found movie, right? We try to find the movie. Let's do this. We say loop over the movies data and find the movie where its name equal to whatever we pass in here. Now we will get the found movie, and in order to consume it, we need to do this one, right? Resolve to found movie. Now when I try to consume this Promise with the done from anywhere, I will get this result. Now I'm trying to use this, but I need to consume it, right? To get this data, this one. And I'll do, let's say, found movie, and just return found movie, or let's just don't return, just console log first. And then return maybe. Because remember, this one is synchronous. When you run this is not going to wait for this one. It's again going to console log. Let's clear this and save this. As you can see, we get pending from here because it's not going to wait. Since it's not going to wait, the promise starts with pending state. Remember, this is why we get promise pending. But inside here, we get our movie that we searched for. Remember, we consuming our promises with the then handler. In here, we consume get movies, and then we consume the find movie, and it's also the promise. Notice. I have a question. What if I just forget to, let's say I do something like this. What do you think it's going to happen? We resolving movies, right? We resolve with the movies. But what is movies? In here, movies is empty array. That's safe. As you can see, we got undefined. Because when we consume the get movies, when we do then, it's going to give us this one. Because it's going to run, right? And it's going to give us empty array. And this is why we try to find movie from empty array, it's give us to undefined. If we do something like this, you'll see we get empty array. But what if I do also like this? Let's say I'm new, I'm learning the promise, and these are the common mistakes that we can do. What do you think it's going to happen based on knowledge you have? Well, when we run this code, it's going to resolve, right? And since a promise resolved, it cannot resolve again, right? And this is why the answer is not going to change. If we again clear, save, you see, it's not changing because it's resolved in here. When setTimeout runs, well, it's going to run, but this is not going to work. If you want to see, am I running? Save. See, the setTimeout runs in the web API, but this will not work because it's already resolved. And these are important. Let's move. So what is promise chain? If you want to do a synchronous operation more than two, this is the idea where we have to use the promise chain. Like prepare the video and then to edit and then publish, so on and so forth. Let's see in examples. We have a function and it returns a promise, and then we try to use this function. Notice we initialize it. Since it returns promise, we can use then on it. And the then itself is also going to return the promise behind the scene. And this is why we can use then. Again, the then method handles these things behind the scene by itself. Now we get the number 1. Since we return resolve from here to 1, we will get number 1. Then we do multiply with 2. Then we will get number 2 because the result of here is going to be 2. We're using the shorthand, means this is going to immediately return. You can also do something like this if you don't know. They are exactly the same. And then we do again multiply 2, then we get number 4. And we console log it. If we save, as you can see, after 1 second, it's coming here immediately. Because inside here, we're not doing something like set timeout. We don't have set timeout in here, so we're not going to wait again. We are just waiting for here. And this is why it only takes 1 second. It's not taking 3 seconds or something. It only takes 1 second. Pay attention. See, let's remove this one, and this log is this one, because remember, this is synchronous. I know I mentioned this one so many times, but it's really important. Also notice that this is not callback hell. It's chaining. We chaining the results. This is not callback hell. This is completely fine code. Let's move. This example is to show you that this is the callback hell. Notice we have this same function, and I create an helper in here so that we can do then on it. And notice this is just a promise, and it resolves to 1. And this is the common mistake that you might do. When I was beginner, I did this mistake always, and I couldn't understand what's the problem, because notice we are doing then while we use the correct, right? This is the correct, but inside then on the promise I use again then, right? And since I use then inside then, it became like callback hell. Notice also the VS Code gives you the recommendation that this is can be converted to asynchronous. Means if you carefully watch your code, you can accomplish the same thing without using callback hell. Let's move. This example, notice we do then and we get the value. This code is not same with the chain, because you initializing each time this function and you expect to get the value which will be always 1. I mean in this case 2, but what I'm trying to say, you're not going to get 4 or 8, whatever. See, we will get 1 because it's first phase, we're just doing chaining one time. Let's move. This example is another way to represent to chaining. Also notice we explicitly return the promise and we do setTimeout inside, and then we consume whatever result is from here. Notice we wait 1 second each time, so when we save we will get logs like 1 second in here, 1 second, and then this one. Notice in the last phase we're not waiting 1 second. After this 1 second, when this is logs, this will also log immediately. Again, 2, 4, 8. You see 4 and 8 happens at the same time. Also, this code shows that you can convert this idea into something like this without doing callback hell. Let's move. Remember about the preparation of the video that I talked about? Let's implement this in the promise. Remember, whatever takes time, it should return the promise. And this is why preparation of the video will take time, and this is why we have to return a promise. And same for here, the editing pace is also going to take time. This is why we also return the promise. Let's say the preparation will take 20 days, and imagine this is 20 days, but for now we will do 1 second, but at the end we will get the video ready for us. After having our video, we'll pass in the edit, then we will edit it, and let's say it will take 3 days. At the end we will have our video ready for the publish. Now if we want to consume these promises, we would initialize this, and then we will do then we will get promise video, right? the console log will run, and then this one, we will return promise video. What is promise video? Well, whatever return from here, right? Let's save and move the with the log so it will make more sense. Let's save. Now we initialize this and it's going to run this function. Then we will run this code, and since it's going to happen in setTimeout, this log is going to log, and then this log is going to log. This value is going to be the resolved value. This is why we get one video, and then we returning this value. Just because we return in here, we will use it inside here if we do that. Remember, this is behind the scene is going to provide promise. It's happen automatically behind the scene. If you return something in the then, it's going to be a promise. This is why we can use then. And notice edit phase is initialized inside here. This log is going to log first. Then we pass the ready video into the for the editing, and we returning the resolve means this one. So after 2 seconds, we get the ready our video for the publish, and then we just want to use it. We console log it to see if it's there. Maybe you can have publish video function in here, function publish it or whatever. Then you can use this ready into the published, and this is how it's going to work. Let's move. Also, the quick information. Notice that when we do something like this, we get the value from the this then, and then we pass into the function as an argument. We have something like this. This is going to do the same thing in here. If you don't have console log or something, you can do like this. So it's more readable. It's just preference. Let's move. What is denable object? We said that when we do then method, it's going to return always promise until now. We said this because to make things more simple. And sometimes then can return denable object, which is the same thing with the promise. It's arbitrary object that has .then method on it. We have these things because sometimes third-party libraries want to implement something different by their own, but behind the scene, it's going to be the same idea with the promises. Let's see an example. This is our denable class, and we have then method on it, and we have resolve and reject. Then we do setTimeout. After 1 second, multiply with 2, whatever this num is. And below we do new promise, resolve with the 1, and then we use this one into here. But inside then we do new denable class, and we pass this one into there. So this is returning the denable object, but behind the scene, JavaScript will understand if this class has then method on it, it's going to treat it like the promise. This is the feature of the JavaScript, so that we don't have to use inherit from promise class. So this is make things more clear and simple. and then we pass num2, means we get num2 from here, and we log it. If we save, we will get 2. Notice its work. We pass 1 into there, and it gives us to 2 because it multiplies with the 2. After 1 second, we get the num2, and we just console log it. And these notes are just the thing that I explained to you. So the key thing is when you return a thenable object, which will have then method on it, the JavaScript will know that it's going to treat like a promise behind the scene. Let's move. Let's understand fetch method that is built in the web browsers. Now we have an URL which will fetch from this endpoint, which is JSON placeholder. We will get just user 1. If we fetch the URL, this fetch returns the promise. So since it returns the promise, if we save, well, we just get nothing. I mean, we have to use then method to get the response, right? So if we do like this, let's see what we get. We know that this is returning promise, and in order to consume it, we will use then, and we will get the result. You can say result if you like. And the result or the response, convention is response. Now we get the response, and in the response, we also have JSON method that we can use because it's on the prototype of the response object. And if I return respond.json, the JSON method also returns a promise. If you want to use the whatever you return from here, you have to use then, right? And this is why to get this value, you have to do, let's say, value, okay? And let's see what we are getting. If we do this, save, well, you can see we get the value, right? And response.json is our JSON value. And this is how it works. And the shorthand usually is like this, just like this. Let's see some examples. This example is close to a real-life example. Essentially, we have p tag in here where we grab from here, and then we have this endpoints that we try to fetch data from. We do a bunch of stuff inside here. I'm not going to step by step because I think it's really clear until now if you pay attention. Now let's save what's happening. We get log inside here, right? We fetch the users. We console log the user in here. And then we say 2 seconds passed. But notice we removing the p tag content. And in here, we filling it. In here, we removing it. Means 2 seconds, it's going to stay with this name. Let's save again. You see, it stay there, and after 2 seconds, it's removed. Now, my question to you, how you can work again after 2 seconds? The 2 seconds happen and you remove, but after 2 seconds, you still want to work with the user. This is hard to explain with the word, but let's jump into the answer so that you really get what I'm trying to say. Imagine that this user details variable is not exist, but we want to use it inside here. I put this variable in here to make things more simple to work with. I could put the promise and resolve with the object. This would bring complexity to the example. So I put like this to make things simple. Now, the question is how we would achieve that goal that we want to do. Let's say I do return user details in here and I save. Well, it's not going to work, right? Notice it's return undefined. Well, there is the only one way we can do this, which is using the promise, right? And let's do this. I convert this to the promise, and notice I'm not resolving yet, but we didn't get the log. So I have to resolve this user detail. So I save. Now I get my correct result, right? Now if I do, okay, after 2 seconds, I want you to do p tag dot text content is going to be new value. Let's save. Notice it's removing, and after that immediately it gives the new value. Well, you might say we even didn't use this one, but this is not the point. The point is that we get this value inside here. What if I now comment this, but I use this one? Like, what about this one, this code? What is the difference? I put console logs in here to understand better. So let's save again. Notice that this code did not trigger because we're not resolving something in here. And this is why this is only going to run, and after 2 seconds, it's going to remove it. But if we had like this, we would have new value at the end, and it will remain because this is what we're doing. Now, the key takeaway that we getting whatever value we want from the previous then into here, and we work with that object, which is this one. This is important because the object can be really important. The object can be, let's say, from here, right? Maybe you pass object from this to there or something like that. Maybe you just work 2 times and then you won't work again. And this is how things work. Let's see how we can handle with the errors. We have this example and we have try catch method. We will try to run this. If any error happen, we will catch it. Notice we just throw in here. Also, this function is not promise, right? So it's not going to matter. Even if we do this, it's not going to run these things because it's not returning promise. Let's save. The error catches in here. If we remove this too, it still will catch. I just put this two to trick. Let's see another example. We have a note in here. We say promise or then method has invisible try catch inside itself. So when we do catch like this, this is why we can catch the errors inside. And it's only going to catch the synchronous code errors. Now we have this function, it returns the promise and we just returning the error. And inside here we try to catch this error, but we also wrap with the try catch block. So if we save this code, you'll see that we catching the error in here, not in here. We catch the error inside here. If you comment this and save, in this case we couldn't catch the error. Let's move another example. I mentioned about this one before, that this catch will be enough to catch any error that happens inside here. So a single catch can handle any error that happens in here. So if error happen inside here, it's going to catch, or here it's going to also catch. Let's move. This example, we have two catch methods, and promise immediately return an error means throwing the error. This catch is going to catch this one, right? Because it's first one. And then this dummy code is going to run. Let's save. This catch will not trigger because there is no error in here. Let's move. This example is similar to previous one, but it has some important idea. Let's see what we're doing. We have throw of error, and then we try to catch it, and then we again throw the error inside the catch method. The idea in here, let's say you get the error and you catch it, but let's say this catch method, you implement some idea that this catch is only going to catch the type errors maybe, and you got the network error. So you say, hi, I cannot handle with this error, I will pass to another catch method. And this is why we throw another error. Maybe you will pass this error, or maybe you will pass another different error. And then is not going to trigger because we're not returning any value in here. We throw the error, and then the catch is going to catch this error. That's safe. You can see that we catching the error, and then we catch a second error in here. Let's move. You can see that this is the simple example, right? And we are going to catch the error. If we save, we catch the error. What about this one? Do you think we will able to catch the error? Notice that it's inside the setTimeout and we throwing the error. Do you think the catch will able to catch it? Let's save. Well, it didn't catch it, right? What about if I change this one to reject? Do you think now we will able to catch? Well, let's save. 2 seconds pass and we able to catch the error. Up until now we said the throw and reject is not going to matter, but when it's inside the asynchronous task like this, it's going to matter. Let's move. We covered similar example about this one, but I just want to quickly mention again, what do you think about the console log order is going to be? Which one is going to first log? This one or this one? If we save, this one is going to first log because this is synchronous. It's not going to wait for the promise to resolve. It's going to run immediately. And this is why we get this one and then this one. Because JavaScript read this and say, oh, this is a promise. So I will just move it to job queue. And then it comes here, it's log it. And then we get the result from here. Let's move. We can solve this problem that we have to convert our code like this. So now if we save, we will get correct order. Let's move. Imagine that you have code, but somehow you forgot to handle with the errors. You forgot to put try catch or catch methods on the promises or asynchronous code. How can we catch these errors? Let's see. If we do this, we will get error, right? But what about this one? Notice we do the same, but we have window at event listener, something called this one, unhandled rejections, means we forget to put here catch, right? And the job of this event listener is to catch these errors that we forget. You can think it like a global error handler. If we save, notice that we get the event, right? Means this triggered, means we catch the error. If we put catch in here, If we save, notice that this event didn't log because it didn't trigger, because catch handled our error that we got from here. Let's move. Notice we have promise, but we don't have catch method, and we reject it. And then we have setTimeout. And then we have global handler. If we save, you see that this is triggered, means this catch this one. It sees that this is don't have any catch, and that's why it triggers. About setTimeout, after 2 seconds, we run our promise, but we put the catch method. We catch the error that happens in here, and we log it, and it's going to catch it because we put the catch on it. Let's move. What about this one? We have again a promise which doesn't have any catch, but then we run it with the catch, we handle it, and also we have global error catcher. Do you think this is going to be trigger or not? Let's save. Well, it didn't trigger because we run it in here and we want it to catch. This is why it's not going to trigger. If we had something like this, since we initialize our promise, it's going to handle for us. And this is how it works. Let's move. Let's talk about Promise APIs. And the first one is going to be Promise.all. Basically, it's about give me all or give me nothing. We will understand this. So it takes an iterable, usually an array of promises, and then returns a new promise. When all promise resolved, then that new promise will also resolve. Also, you can even pass the non-promise array inside them. It's not going to complain, and the order is going to remain the same, means the orders is matter. If any promise is failed, the Promise.all will fail. So any of the item, the promises that you passing inside this, if any of one fails, the Promise.all will fail. Let's talk about this example. You see that we have 3 promises and it just resolved, right? After 1 second, 2 seconds, and 3 seconds, it's going to resolve, and we want to get the value. As we mentioned, it's an array and each of item is promise. So let's say if this one is failed, the result is also going to be failed, means it's not going to resolve. If we copy this in here, let's save. You see 3 seconds pass. So it's going to wait all of these to resolve, and only then it's going to give you the answer. In this case, answer is going to be A, B, C. We return A, B, C. We pass the array and we get result as array and each item inside the array. If you do reject in here and save, it's going to reject, means you have error. So you can do catch and you can catch the error basically. This is a detailed note, but I want to mention it still because it's something good to know. Imagine that you have multiple fetch. Just imagine that these are the fetches. And let's say one of them failed. The other will keep running because you start 3 of them at the same time. Let's say this one is failed, but this 2 is still going to run behind the scene. But it's going to ignore their values. This one is rejected. So when any of this rejected, at the end it's going to also fail, but it's not going to cancel these things. You might say, okay, what is matter? Well, it's matter because imagine that you fetching from the database. Let's say you fetch in here 5%, you fetch in here 100%, and you fetch in here 300%. When this one is failed, it's not going to stop them, but you will get rejected at the end. But having the idea this too is not going to be cancelled is good to know. Let's move. We have 3 URL in here, and we get users 1, to-dos 1, and post 1. And then we have multiple promise variable. We do map, we fetch the URLs, and we having the promise array when we do this, right? So it's going to be a promise array. And we pass this array inside the Promise.all, and then we try to get the response. And then after we get responses, what we can do, we have to do promises.json, right? Because it's going to be what? It's going to be multiple promises inside an array. And this is why we do map. And then we do response, and each response.json, just like normal fetch, remember? But this is the multiple, so we have to handle these things. We have to think about them. And then we return Promise.all. We again pass the promises that are in the array. And now we get the JSON data from here, and we loop over them to log. If we save, notice we log in here, right? We get the result that we're looking for. We fetched these URLs and we get the data. Let's move. Promise.all.settled. What is this? In this case, when any of this failed, we still interesting the result. We still interesting what we are getting. Normally with the all, when anyone failed, we just reject, right? But in here we don't reject. We still want to get the answer. And when we save, now you see we reject right in here. But even though we reject in here, we still get the answer. Notice we asking for the result. When we extend, you'll see we get the answer, and it's going to give us about the status, whether it's fulfilled and rejected, and it's going to give us value or reason. If it's failed, it's going to give us reason. If it's succeed, we will get the value, which is A. Let's move. Promise race. Promise race, as its name, it only cares the first one, who is the finished race, thing like that. And it doesn't matter even if it succeed or failed. It wants information about that first person. So in this example, you can see we have 3 seconds, 2 seconds, and 1 second, right? If we run this, you see after 1 second, we get the C. And we didn't wait for 2 seconds or 3 seconds, right? We just got our C and it's finished, it resolved, which is succeed. This is why this is triggered. But the important thing is that after 1 second, it's done. It's not going to wait for this too, because this is race. Who is the winner? And this one is winner. And even though if you do reject on here, since it's the first one is going to finish, if we save, we still get C and we catching in here. As I mentioned, it's only care about the first one, the finished, whether it succeed or failed, it doesn't matter. If you put this 9 and maybe like this, you will understand better. See, we get this lag. Let's move. Promise.any. It's really similar to race, but this one is only cares about the first one who succeed. Let's check an example. We have this one in 3 seconds. Well, obviously, let's do this resolve first. And we have like this, and then this one with 1 second, it's going to resolve, right? If we save, now you can see we get the first one who succeed, and which is C. But if I change this to reject, notice this is going to fail, and this is also going to fail, but this is going to win, right? We will get resolve. And if we save, let's check, you see we get A, because these two are failed, and the any Promise.any doesn't interesting when someone failed. It's only interesting in who is the winning, who is resolving. If you put something like this, we will get in 1 second. What about if all of them is rejected? What's going to happen then? Let's see. We have 2 promise and both of them is rejected. Means we have no succeed promise in here. When we save, you see that this is not work, but this one is work. It will have aggregate error, an object, special object that will have a property errors, and this errors is going to have an array of all the rejected values, and by accessing index we accessing the rejected values like this. So basically when everything failed, when we get the error object, this object is going to be special object, and we can do e.errors. It's going to give us all the failed values. Let's move. Let's talk about promise, resolve, and reject. When I log the promise, you can see we have reject and resolve, right? And these things came from here. So when I do let promise like this, it's going to resolve the one, right? And this is same when you do this one. So it's up to you whether you use this one or this one. We usually don't use these things, but they are exist. Let's see an example. Imagine that we have a function like this. It takes URL and it fetch that URL. Actually, it should be like this. The problem is, let's say we pass the number, right? If we pass the number, if the thing that we pass is not string, let's say, it's going to trigger this one, and this one is going to also return the promise, right? So by having this logic, now we can always use the then method on it, right? Because we either will trigger here or here, and both of them is promise. What about the reject? Well, it just exists there, but we usually almost never use it. The idea is same, they are same, so you can use this one if you like. It's there. Let's move. What is Promisification? It's really hard for me to pronounce, so probably I will not pronounce it again. So let's say you like promise more than the callbacks. And if this is the case, we can promisify our function without passing callback in it. So let's understand. We have a function like this and we have version callback. We pass the URL and callback, and then if we get the data, in this case true, then we do callback, right? We do null. Imagine this is the first error. Callback, we pass the error at first if it exists. In this case, it's null. And then data. If it's failed, we pass our error. You can ignore this if you like. Let's convert this idea to this one so that we will not use the callback. This is the new version. As you can see, we return the promise and we assume again that we get the data somehow by using URL, of course, in real life example. And then if we have data, we resolve. Here is your data. If we don't, we reject. And now I can do then on this function that we changed its logic. Now I can do then, I can do catch on it, and we prefer this version more than this one nowadays. If I do this and save this, you see that we get the data. Here is the important note about this topic. I said we prefer nowadays this version. Well, that's true, but this doesn't mean that Promisify is going to completely replace the callbacks. The callbacks is always going to exist, and you have to understand how it works. Remember, you technically can call callback many times, right? In the function in here, for instance. Maybe you can call callback that is getting data from somewhere and you use it, you change it, you call another callback or the same callback. You can call it many times. But about Promisify, you can only have one result, right? And this is difference between these two. So basically, if your function calls callback only once, Promisify is perfect way to go. And usually you call your callbacks only one time. But this is just an important note. Let's move. What is Async Await? This is one of the most exciting things that happen in the language. It is the special syntax to use promises. It will remove complexity that we had before. Remember, we removed complexity of the callbacks with the promises. We used then, catch, finally handlers, and now we are going to learn Async Await. And by using Async Await, we will not use then, catch, finally handlers on the promises anymore. But again, in order to able to use this syntax, we truly have to understand still callbacks, promises, how things work. This syntax will let our code to be like synchronous code. We will get there, don't worry. If we put a synchronous before a function, that means that function will always return a promise. And then we can use await inside that asynchronous function we have. This is a quick example. Let's say we have a synchronous function and we can use await inside. If you don't have a synchronous function, you cannot use await. As I said, await is only going to be exist in the asynchronous function, and we will use await before promises so that we can await for that promise. The whole idea is like that. So await will wait for resolve or reject to happen. Means it will wait until promise settled, finished, either resolved or reject. So by using await, we're not going to need any more than or catch. Await syntax is more clear and easy to write and read code. And this is the most benefit of using async await. It's amazing syntax. And we can use await for deniable objects. If an object is deniable, then we can use await, and it's going to await for the resolve or reject. And lastly, you can use asynchronous for the class methods. If you have class, you can put asynchronous keyword before any method that you want. And that method is going to be a synchronous function or method. Let's move the examples. We have a synchronous function and we just return a value. Since this function is a synchronous function, we can use then if we want. I'm saying, hey, run the function and then give me the result. What is the result? Let's save. It's going to be 22. If I also do this, you see it's a promise that is pending. This code will run because it's not going to wait for this to resolve. Let's move. This is similar to previous one. You see now we resolve with the promise, right? But before we use return. And asynchronous, as I said, it's going to always return promise. Behind the scene, when you say return 22, it's going to wrap that thing with the promise. So now we explicitly saying it's going to return the promise, and we can still use the same logic. If we save, you can see that we get the same result. Let's move. We saw this example many times, so I'm just going to explain. You see this lock is going to lock before this one, because this is a synchronous function. Now I remove this. What about this one? Remember, this is also a synchronous function. We have promise inside. We do like this, and it has setTimeout inside. Now we want to wait for this promise to either resolve or reject. We will wait until it's finished. In this case, it will finish in 1 second. Let's save. You see we wait, right? We console log this one, which is the resolve, which is this one, and then only then it start to move to next line. So this code is not like before. We waiting for promise to resolve or reject. It's like we sit there and waiting for this to finish. If I put, let's say like this, we will wait until this time is finished. I mean, this code is finished. You can see we waiting. It's not logging this one. But if I do something more fast, you see that we get the log. So whenever we await for promise, it's not going to move the next line. It's going to wait until it settled. What about this code? What's going to happen, do you think? Well, we still have promise, right? And we still wait for it. So what's different? Notice that we're not using resolve or reject, right? We just console log and we do nothing. And we said if we put await before promise, it's going to wait. Either it's resolve and reject. What if it didn't, right? What if we forgot? Well, in this case, let's save. You see that our log is logged after 1 second, but program is here and it waits, and it's going to wait forever. It's not going to log this because we are saying the program wait for that, and the program waits. That's all. It's not going to move here. You have to either use resolve or reject if you want. Also remember, if you do like this, let's say like this, outside of the set timeout, and if I do this like this each time, if I save, now you can see, since we resolved in here, it's going to move, right? Let's put this to 1 second or maybe 2 seconds. Let's save. You see it's locked, and after 2 seconds this one is locked. So it's really important where you put your resolve and reject, because we read this, we put this to web API, and then it keeps moving and it sees the resolve. As soon as it's resolved, this code is start to move because it got its answer. So this is why we will get this log first. Let's move. Remember, we have example like this where we edit the video and prepare the video and then edit it and then ready for the publish. I want you to convert this entire code into asynchronous await syntax, and you will see how it's really benefit your code. I will just pass the solution here. Please try to do by your own. The solution is going to be similar with this one. This is also the solution, but for a purpose I made some errors, some mistakes, and I want you to find this error at first. Let's briefly talk how we convert things, and then we will move the errors. See that we use this function in here and we just convert the asynchronous function, and then we don't need anymore the promise. We can just use setTimeout, and then we return this value inside setTimeout, and then same logic in here. But really notice between this function and this thing that we done with the then catch or just then. Do you see how clear this code is? You just write like synchronously, right? Line by line, you can read what you're doing. Hey, wait for this, and then wait for this. We're waiting for the video to prepare, and then we take the prepared video or promised video to edit so that we can edit it, and then we get the result of the ready to publish, and then we just want to log it. Let's see. If I save, you see we immediately got undefined, right? I will save again. You see we just got the undefined, and this undefined is this one. Well, didn't we say it's going to wait? What's happening? Yeah, it's going to wait, but if you have, remember, resolve or reject inside, but we didn't do something like this. I said we don't need to promise, right? But actually we need to prepare promise. The reason I said we don't need promise, usually in the asynchronous function, if you return something like not inside setTimeout, it's going to give you already promise. But you can see that this code, it's actually waiting. But since it sees, well, it doesn't have any resolve or promise inside, so it keeps moving. It sees this, it passed to web API, but then it just return undefined. It resolve with undefined, I mean. If we had resolve in here and this was wrapped with the promise, then it would wait for this, right? The program will know what's happened inside. And this is why it just moves. I mean, it knows the answer, undefined, it comes here and it gives you undefined. And after 1 second, this code runs, and then this one runs 2 seconds later. Let's give the true answer so that you really understand what's happening. Okay, this is the answer. It has really tiny missing part. If you can catch it, this will be really good. But let's talk about the answer. Notice we just convert this to promise so that when this code runs, we can wait for the promise to resolve, right? Because we can do this. This is a synchronous function. And when we initialize this function, it's going to see this. It's going to see that this is the promise. And then we can wait, right? We doing the same in here. We just have promise. We wait for the promise. And notice the difference between these functions and these things. And then we do a wait for the preparation of the video function. We get the value, and then we wait for this one, and then we try to log. Let's see what's going to happen. Let's save. Oh, we get undefined in here. What's happening? Well, we saying wait, but it waits, and then it's return what? It's return undefined. So in order to tag this value, we have to return whatever returns from here. If this is confuse you, you can do something like this and return A maybe. It's same. And we have to do the same in here. So if we save, now we get the true answer. So this is how it works. Please try to do by your own if you're not familiar. So let's move. Remember this code we had before with the fetch, and we used them. Now I want you to convert this logic into the asynchronous await. It doesn't have to be really exactly the same. You can do some other things. This is just for you to practice. I will pass my solution so that you can see differences between things. Let's do this. This is the solution that I bring to you, and you can see how this code is much more clear, readable compared to this one. And imagine that you handle the errors, or you have relationship between the user to do or whatever. It's going to be really mess. And even though you don't need these things in here, because everything will be available in the function itself. And also you can take apart this code, means you can do multiple function, and you can, let's say, get data function, and you just can split things if you like. You can move this task into another function, and then you can call this asynchronous function with await, and it's going to be really readable for you. Let's save the code. See, we have the same result, right? We refresh, we get the name, and 2 seconds later, we removing the name because we are waiting for this thing. And if I do this, it's removed, but now we didn't get this after removed name, right? Why? Well, remember, we have to do something like this in order this to be work. Even though you return something empty, if we save, now it's removed, and then this code will work because this will wait for this one, and only then it's going to run this one. Let's move. Let's see how we handle with the errors in asynchronous await. Let's see an example. We have this asynchronous function, and if we save, you see that we get the error, right? Let's see how we can handle this error. We can wrap our code with the try and catch, and we trying to do this code. If it got any error, we want to catch it inside this catch block. You have to put a variable inside here, and you can name whatever you want. Let's save. See that we catch the error, right? The key thing is that we catch this error happens in here, and it says failed to catch. Notice the line. If I put a log in here, you see that it's really running this block. And lastly, you see that we have a synchronous function that just have this one, but it doesn't have try catch. Let's say we forget or something. In this case, the global catch error will catch it because we define it. Now, if we save, let's clear again, save. You see that this one is triggered, and this 11 is the error that we get, event I mean, and this is how we can catch the error if we don't define. Remember, if we had try catch inside, this wouldn't trigger. Let's put try catch inside. Now if we save, you see that this line triggers, right? This didn't trigger because we handle our error by ourselves. Before closing the lecture, let's talk about details in here with the example. We said when JavaScript sees setTimeout or promise, it's going to pass to web API, which is this one, or if it's promise, it's going to pass into job queue. Think them like a list where the task stay on top each other. If task 1 is come, it's going to be in here, and the second, it's going to be in here. But the important thing is when they will finish. Let's say task 4 finished early, the event loop smart enough to take it. But let's say task 3 and task 4 are finished at the same time. In this case, first in, first out is going to happen, which means the task 3 is going to be take first because it was before task 4. And same concept in here. And event loop something constantly check these two, and when there is a job task finished, it's going to talk with the JavaScript, and if JavaScript doesn't have any job, means it finished its job, and then only then it will accept the task from event loop. Let's see in the code also. we have a code like this. I want you to inspect it and try to please think what's going to happen based on things we learned. Notice that this one is equivalent with this code. I just put log in here so that we can see. And also notice this code and this code are different. We do then on here, right? Means we will wait for something. So let's see the answer if you're ready. We save. Now JavaScript reads code and it sees this and it says, okay, I know this, I will just log it, right? And then it comes here. It says it's set timeout. Even though it's 0 second, it's going to pass into web API list, into task queue, or into callback queue, whatever you call. Remember the diagram? The set timeout is going to pass into here. This one, let's say. Then it will start to move next one, which is this one. And it will log it. This promise immediately resolving. And we're not using then on it. And this is why it's not going to pass to promise. It's going to run immediately because JavaScript know its answer. Whatever you put here, 555 or whatever, JavaScript knows what it is. So it doesn't need any help from outside. Think like that. I might say you before that whenever we see new promise or something, it's going to pass to job queue. I set this to make things simple, but in here, when there is no then, or let's say await keyword, if you wait for promise, it's going to run immediately because it knows the answer. It doesn't need to wait for something. This is why it's going to log immediately. It's going to run immediately. Let's move. In here, we do then. Notice we wait for something. Even though it knows the answer, but then is asynchronous. It returns a promise. Let's say maybe you will do fancy thing in it. Who knows? So this is why it's going to pass into job queue. It's going to say, okay, I don't know when it's going to happen, so I will pass you to job queue. And it will stay in there. It will pass into here. Think like that. And then we see this code. This code is also going to be passed into web API since it's set timeout. And then we will have this same logic. It's going to log immediately, which is why we get resolve 2. And then this one is going to pass into the job queue. This one will pass to web API list, task list, and this one is going to log immediately again. Now, how things work in the other side. Like I said, the event loop is going to check constantly these two lists, but the first priority is for the job queue. So the priority for job queue is more important than web API. This is how it works. If there is a task with 0 second and if there is a task with 0 second in the job queue, the event loop is going to take first one from here because there is no way to take two of them, right? It's going to take one of them and it's going to pass into here if it's ready. And remember, since we finished our application, now it's finished, right? Now the JavaScript ready for to take task from either from the job queue or the task queue. And this is why we get promise consume 1. Why? Because in here you can see it immediately resolve. It's resolving in 0 second. Just like the set timeout 1, which is in here. But as I said, the first priority is for the promise. It will take promise consume and then the second one, because they both finished in 0 second, and then it will start to accept the task finished from setTimeout. In this case, since we pass, first one was this, right? And with the 0 second, and second one was the 0 second, and again with the 0 second, the third one. This is why we get 1, 2, 3. But what about I change this one to the, let's say, 20 milliseconds? Okay, I will save. Notice the log changed in here, right? The 2 finished before 1. Even though 1 was the first task in the task queue, because it's read from the top to bottom, this 1 was the first in the list, right? It was in here, the first one, but it finished later. It had 20 milliseconds, but the task 2 and task 3 was 0 second. So this is why they finished the 0 second, and it takes the task 2 because task 2 added before task 3, and this is why the event loop will take the order, and this is why first in first out is important when they finish at the same time. As you can see, the 2, 3 and 1, we changed the log order by playing with here. What about this one? What if I change the code like this? We put setTimeout inside and we try to do then on the promise. Well, you can see that if I clear and again save, the order changed, right? The promise consume to log first. This is because we have setTimeout in here, and because this setTimeout with the 0 second, it's happening before the other 3 actually. But notice this one is 20 milliseconds, right? If I change this to 0, this technically should first go into the list, right? Task queue list. Let's save. You see that because this was the first one, and now the setTimeout one is going to log before this one. So you shouldn't think that if something is new, promise is always going to be the first log. It's not like that. Just because you use setTimeout, and this is also setTimeout, it's this one is going to log later on this, because this one before this one into the list, because the list is first in, first out. They finish at the same time, but the event loop is going to pick this one, because this one the first one. If I do, let's say 100, right? I save. Now you can see this one logs at last. I hope now this is really clear to you. I want to mention this notes before closing. JavaScript will never run any code from job queue or web API until it finishes its call stack. Like I said, the code will finish from top to bottom. This is last in, first out, or some people say first in, last out. It really doesn't matter. So when this call stack finished, then only then it will start to apply whatever task in here. So the second note, I believe this note is technically wrong, because as we saw that when we put setTimeout with the new promise, well, maybe it went into the web API. I'm really not sure how the behind scene 100% work in this case. But since you got the idea how things work, this is all what it matters. I believe I read this somewhere. I'm really not remember. But what is important is if two things finish at the same time, the first priority is going to be for the job queue. This is all it's matter. So event loop checks them constantly. You don't need to worry. Also, it's smart to not drain your CPU. So event loop job constantly check these things somehow behind the scene. I really don't know how things implemented, and we don't really have to know these details. But the important thing when the event loop check these things, it's not drain your CPU. I was also worried about if it's drain our CPU or not. So as far as I know, it's not going to drain our CPU. Okay, that's all. We finished the lecture. We covered everything about callbacks, promises, promises APIs, how to handle the errors, async await. We saw a bunch of different examples. I hope this was useful lecture for you. If you learned something, please don't forget to support. See you next time. Bye bye.